Hello and welcome. Today we are going to learn about relation between the polar coordinates and Cartesian coordinates of a point. We will also learn how we can find Cartesian coordinates when polar coordinates are given and vice versa. So let's begin. Let's say there is a point P in this plane and its Cartesian coordinates be x and y and its polar coordinates be r theta. We can see here that we can represent the same point by two different ways, one by Cartesian coordinates and second by polar coordinates. Now we want to establish relation between these two. So let's first start by finding Cartesian coordinates when polar coordinates are known. Let's say we know its polar coordinates, it's r theta. Now we want to find its Cartesian coordinates, that is the value of x and y. As we can see here, both of these refer to the same right triangle OMP. So with the help of trigonometric ratios, we can establish relation. So the trigonometric ratio cos theta is equals to adjacent upon hypotenuse. So in this right triangle OMP, cos theta would be equals to x upon r, which we can also write as x is equals to r cos theta. So if we substitute value of r and theta here, we can find value of x. Similarly, sin theta is equals to opposite upon hypotenuse. In this triangle, sin theta would be equals to y upon r, which we can also write as y is equals to r sin theta. If we substitute values of r and theta here, we will be able to get value of y. So this way we can find values of x and y if we know values of r and theta. Let's understand this by an example. Suppose we want to find Cartesian coordinates of a point whose polar coordinates are 5 root 2 and pi by 4. As we can see here, r is equals to 5 root 2 and theta is equals to pi by 4. It means our vectorial angle is pi by 4 and our radius vector is 5 root 2. So this would be the point. Now as we know the polar coordinates, now find out the Cartesian coordinates of the same point by using the same relation which we have just learned. Here x is equals to r cos theta. So let's substitute values of r and theta here. X would be equals to 5 root 2 cos pi by 4. Let's substitute value of cos pi by 4, which is equals to 1 by root 2. Root 2 will get cancelled and we'll get x is equals to 5. So this way we got the value of x by using values of r and theta. Let's find out value of y now. Y is equals to r sin theta. Let's substitute values of r and theta here as well. So y is equals to 5 root 2 sin pi by 4. Value of sin pi by 4 is again 1 by root 2. Root 2 will get cancelled and we get y is equals to 5. So you can see here we found out the Cartesian coordinates of the given point, which are 5, 5, with the help of its polar coordinates. Now let's see how we can find polar coordinates when Cartesian coordinates of the point are known. So this is point, its Cartesian coordinates are x and y. Now let's say we have to find polar coordinates r theta. You can see here the same right triangle OMP. Now let's first establish relation. In this right triangle, let's use Pythagoras theorem, which is sum of squares of the sides which are making right angle of the triangle is equals to square of its hypotenuse. So here r is hypotenuse and the other two sides which are making right angle are x and y. So r square is equals to x square plus y square. Let's take square root of both sides. So r is equals to root of x square plus y square. So if we substitute values of x and y here, we will be able to get value of r. Now tan theta is equals to opposite upon adjacent. So we can write tan theta is equals to y upon x in this triangle. So we can write theta is equals to tan inverse y upon x. So you can see we could find both r and theta when we knew the value of x and y. Let's understand this by an example. We have to find polar coordinates of the point whose Cartesian coordinates are 3 root 3 and 3. Here x is 3 root 3 and y is 3. Now let's apply the relation which we have just learned. R is equals to square root of x square plus y square. Let's substitute values of x and y here. X is 3 root 3 and y is 3. We take square of both of them and add them. And finally we got the answer r equals to 6. Now let's find out value of theta, which is equals to tan inverse y by x. Let's substitute values of y and x, which gives us 3 by 3 root 3. 3 will get cancelled and we get tan inverse 1 by root 3. Tan inverse 1 by root 3 is equals to pi by 6 as we know by trigonometry. This way we could find polar coordinates of the point 6 pi by 6, whose Cartesian coordinates are 3 root 3 and 3. That's all in this video. In the next video, we will learn values of theta in 4 quadrants. Do like, share and subscribe the channel. Thank you so much for watching.